Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
creating sustaining and meaningful software, understanding software holistically, and crafting versus writing the best code. In this conversation with Liran Haimovitch, co-founder and CTO of Rookout, he shares what happens when software systems evolve from monoliths to complex cloud-based systems and cloud-native applications developed on personal machines and running anywhere. How tech debt manifests and what is the main reason for it, and how you manage and build on older systems when they are still generating revenue for a business. Liran shares his inspiration for starting Rookout, which is a platform that helps you understand code and examine it as it's working in real time. He also talks about simplicity in building software, agile ways of working, his thoughts on good agile teams, and as always, listen to his message for aspiring software engineers. Good afternoon, Liran, and a very warm welcome to you to the Software People Stories podcast. It's really nice to have you here with us today.
Hey, Chitra, it's great being here.
So we usually ask our guests to introduce themselves to our listeners. So how would you like to introduce yourself, Liran?
That's always a tough question, I guess. For the first decade of my career, I was a cybersecurity expert doing software development, software research, and some product and project management, as well as tech leadership for the government of Israel. And then about 5 years ago, I left, and today I'm the CTO and co-founder of Rookout, which is what I've been doing for the past 4 years or so. And that kind of became a very big part of my identity and who I am.
Your journey into cybersecurity, technology, and software, how did it all begin? Were you interested in it in your childhood, or did you develop the interest later? How did it all start?
So my interest in computers goes back as far as I can remember myself. I even remember the first computer my parents bought when I was, 5 or 6 years old. It was a very big thing, and we had a special liner to cover it at night for some reason. I'm not sure why, but thank God we're not doing that anymore. And yeah, I've started writing code, minor code for kids and stuff a few years after that. And I've been kind of dealing with technology and software engineering ever since. That's kind of how it all got started. Then I got my bachelor's in computer sciences fairly early on. And as I mentioned, kind of found my way into the cybersecurity world.
That's an intriguing place to start with. And you mentioned in your introduction that you played several roles in your tenure as a cybersecurity professional. So how did sort of that shape you as an engineer, as a manager? I'm sure you got opportunity to understand what your customers are looking for. So how did these experiences help you evolve in these various roles and perhaps into what you are today?
I think my work on cybersecurity made two most profound impacts on me. The first is the importance of understanding software on the one hand and the complexity of software on the other hand. I mean, there are so many layers. Obviously, our own code, which there can be very plenty of, especially if we're working on older systems. I mean, our code, our team's code. There are also open source libraries we're using. There is the runtime below us. And then you can go into the operating system and even in some cases, the CPU itself. And there is so much that is going on across all those elements. There's just so much to understand, so much to know. And obviously, nobody can know everything. But the more we are able to piece together what is going on, the more we can understand each abstraction and its purpose and how it's all coming together. we can actually make things work that we never thought was possible. And that's kind of how I later come to found Rookout, which we can talk about in a bit. Just the feeling that as many layers as there are, and there are quite often many, many, many layers when it comes to software engineering, we can always learn through them. And the more we understand them, the more powerful we become as software engineers, as product designers. The other thing that I think made a huge impact on me is that the fact that as someone who was working for the government, who was working for a mission, I think for many software engineers out there feel it, some of them don't. You get a very strong feeling that you're doing something beyond just writing a software. You're working on some kind of mission, something bigger, and you're really trying to make that impact. And in order to make that happen, you have to keep in mind that things go beyond the tech you're working on. What impact you're making on your customers, on your stakeholders? How is the software actually being operated in the real world? How is it serving your customers? How is it failing to serve your customers? Whether it's a missing feature or a bug, being able to see that impact and care about it and facilitate it and improve it, those are all key elements in creating successful and meaningful software. It's not just about the quality of the code we write.
Yes, software success, I suppose, in many ways has so many dimensions, and particularly for software engineers to consider as they write code. And I, have so many questions on those fronts in terms of how our education system itself around how software is taught, or if somebody wanted to learn about software, what is it that they need to look out for, and how can they be better builders and makers of software? Very interesting perspectives there. Thank you, Liran.
Mm-hmm. Yeah, software is much more of a craft, but there's a lot of practical elements to it. It's not purely academia, and as much as knowing your algorithms is important, especially in various elements, there are things that go even deeper. There are being able to craft the best software goes way beyond writing the best code.
Yeah, I can certainly imagine. I mean, one thought that's coming to my mind is that from an engineering discipline standpoint, software is relatively younger when you look at some of the other classical engineering disciplines like architecture, civil engineering, even mechanical engineering. They have been around for several hundreds, if not thousands of years, and they must have gone through a similar evolution. Mm-hmm. And like you said, they too have multiple layers. And it's interesting that you said that learning software is a process of layering. And I guess we've seen it evolve through layered architectures. One thing that comes to top of mind is this whole OSI model, which was, again, a series of layers. A lot of systems today are, monolithic. They were built many years ago, but they work just as well. A lot of, let's say, banking software, airline reservation systems, and many other things that were probably built with different architectures. A lot of times, at least in my experience, I've seen that many engineers that come on board to companies struggle to understand what was written and why it was written in a particular way. And more often than not, especially when you encounter a customer issue, there's a lot of hesitation to see, hey, which line of code do I need to change? And then if I make this change, how can I minimize the collateral damage around it? What has your experience been? How can people manage their monolithic systems better now?
My experience has been that the impact of all systems is often huge. I mean, there are all these new cool new systems, whether it's a cloud native or serverless, and those systems are shaping up to change the world someday. But right now, for most companies, the core of their business, the core of their revenues is built on older systems, whether it's a Java monolithic web servers, or it can go back to COBOL environments for banks and stuff. So we must not leave behind the old stuff, or at least not leave it behind too soon, because it's still with us. And time again, we see that for most companies we're working with, the most important systems, the most revenue generating systems are some of the older systems. Now, old might be 5 years old, it might be 25 years old, depending on the company. But in a way, I think a system ages whenever a generation of maintainers moves on. If a system is still built and maintained by the people who first wrote it, by the people who first built it, then it's going to be considered relatively young, regardless of its actual age and technology, because the people who work on it understand it. But every time we have a generation shift, every time the team changes, a lot of knowledge gets lost. And much of the ownership, the feeling of ownership and accountability also gets lost. And every time the next generation has less information, less knowledge, and is forced to patch upon the existing stuff. And so time and time again, a system ages. And those generation shifts can make that impact, where people come into a very large, complex system, or sometimes just a system that they don't know, that the documentation is out of date, that nobody knows what's going on, that you have a huge code base and you have no idea where to start. And that so much of the ordering logic, so much of what has been designed kind of is lost to time. In many ways, I feel that that's the most common form of tech debt. It's not necessarily that the code is bad or that it doesn't do its job well. It's that nobody understands truly how the code is achieving that and why it's achieving that way. And that's a huge problem we're seeing for so many customers, for so many companies in the industry.
You actually touched upon a question that I had perhaps intended to ask, which was tech debt. And so do you see tech debt more of a function of understandability of the code?
I think tech debt tend to usually falls into one of three categories. The first is the code that is truly bad, code that was written poorly from the get-go. I honestly have to say that that's the vast minority of cases. I mean, if the code has been written poorly from the get-go, then it probably wouldn't have been successful from the get-go. If a code has been there for 20 years and has been performing adequately, it's hard to say that 20 years later that wasn't written well enough. That's the edge case. Tech debt is quite often more that when you wrote the system, it was designed to do one thing, and then as time moves on and the business requirements change, you all of a sudden use that same software, that same code to do something else, and it's not quite as adapted to do that other thing. As time moves on, and that as other things move away from the original thing, and then you do create that kind of tech debt. The number one tech that we're seeing working with customers is that they just don't understand what's going on. And they're not sure, is this good? Is this bad? Why is this loop behaving the way it does? And why is this function calling that function? Is it necessary? Is it not necessary? Is it something that was left over from the past? Can I change that? Can't I change that? That kind of brings, I have to say, sometimes fear to engineers' life. I mean, if you're making a change to the system, that you're not sure what's going to happen, and then you're going to push that change to production, you're going to push it to a customer environment, and you're not sure what's going to happen, that's not a good feeling. That can often inspire fear, whether it's just worried about the impact, or sometimes even what will happen to my company, to my team, if I make a mistake here.
Yeah, I can certainly relate to that, having been in several situations like that, or even having seen my teams go through it. So before we talk more about other aspects, I wanted to ask you what made you turn to entrepreneurship, and how was Rookout born?
In a way, I've always wanted to build a startup. I think that in Israel, it's kind of a dream for many people, especially software engineers. And then at some point, I've kind of figured out, I think it's time to do it. I'm not even sure what I'm going to do it about. First, I decided I want to go in, try and experience that journey. And so I took my own frustration that I've just shared with you, that software can be terribly hard to understand. And it can be so frustrating, whether it's a piece of code you wrote, or even worse, a piece of code somebody else wrote, and you kind of took over for it. And then stuff goes wrong. People come complaining to you, and you have no idea what's going on. And that code that's staring right at you from your IntelliJ or Eclipse window is not actually there. It's running remotely somewhere, and you have no idea what's going on. Where is that code running? What's happening? And I can even think, I remember one project, I got handed off the project just as it was launched. The team who worked on it left. And then after a year, which I barely worked on that project, it was handed off to another guy, which handed off to another guy. But they didn't actually get all that knowledgeable about it either. So years after I handed it off, people still kept calling me. I mean, they were approaching the so-called appointee, but he didn't know much. So he came to me and I didn't know that much either. And it's just so frustrating that you own a piece of software and somebody's calling you and say, why is this happening? And you're looking at the code and you don't know it all that well. It's kind of, I don't know. That's kind of how Rookout was born. What if we could show you what that code is doing on the live environment? What if I could make that shift from just seeing my code statically on my IDE or seeing it running on my machine? What if I could see how the code is executing in the remote environment, in the customer environment, in the cloud? And by seeing that, I'll actually be able to understand what's going on, to put it all together. Because in a software application, there's actually so much more than just code.
And to actually be able to do that remotely without disturbing the environment, but purely from the intent of understanding what's happening there. That's a great idea. And what happened after that? So how would you now look at understandability of software, or how would you say that you are able to enable software developers who either are handed over code or who have to maintain code? How does their life become easier now?
So there are quite a few steps to improving understandability, but I like to think of Rookout as the ultimate shortcut. There are definitely quite a few things you can do. You can create better test and development environments. You can curate better test data. You can try to reduce the complexity of the system. You can try to accumulate knowledge and distill it and share it. But at the end of the day, Rookout just offers an amazing shortcut because it allows you to see in real time what's going on. And you have to think, as I mentioned, software applications, they go way beyond just source code. Obviously, source code is the base of every software application, and that's what we all think of when it comes to an application. But the truth of the matter is that software applications are also comprised of state and configuration. And for many systems, that can be huge, whether it's the per account configuration or the environment configuration or the state stored in the database or in memory. Those things can make a huge impact. You also have the runtime environments. Often there is a huge difference between running on your laptop and running in the cloud or running in the environment, whether it's the number of processors, the amount of memory, the throughput of the requests, the amount of instances you have running at the same time, and so on and so forth. You also have the inputs and outputs of the system, which are also huge, and especially in a more security sensitive environments or just very large environments, you just can't get access to the inputs, to the relevant inputs in your dev environments. And so you're guessing what data is coming in from the internet, who is calling me, how is it being called, how much data. Kind of by seeing all of those things, how do they come together? By seeing how my code is acting right now, what configuration is loaded into it, what's the state, what inputs are being received, you can paint a much clearer picture and just know. And then you can make whatever change you need to make with confidence, whether it's a new feature you're trying to develop and you're not sure where to start, whether it's a bug fix you're trying to locate or even just test out. So now you're making a big complex change to the system. And the more you can understand about the flow before and after the change, and the more you can see into it, the more confident you become that you know what you're doing.
That sounds really interesting. Thanks, Liran. You said that you had some interesting experiences to share about customer issues and especially the impact that it has on businesses, because typically these kind of escalations or issues are more often than not unplanned, and they can, disrupt a lot of things for, a software company that's providing those services. What are some of those experiences that you can share with us?
There are so many of those. I'm not even sure where to start, but I think you've mentioned monolithic systems. And I think one of the pains we're seeing quite often, especially when it comes to Java application servers, is just huge build and restart times. One of our biggest customers had a WebLogic server that took about 40 to 60 minutes to restart and another 20 to build. That was a pretty big WebLogic. It had about 50 some wars, thousands of threads. So you couldn't touch a debugger to it because it would slow down to a crawl. And the only way they could debug was through adding log statements. But those log statements had to involve a rebuild and restart of the application. And so whenever you wanted to see what's going on, even in a development environment, you had to wait upwards of an hour. And that's just crazy. It means that for any full workday, you could push maybe 3 to 5 logs to the environment. Now, something is going wrong with the system, whether it's a development bug or a production bug, and you're working so slowly, encumbered by your tooling, and that was driving them crazy. And using Rookout, which actually haven't discussed all that much, they can just go ahead and get the data in 5 minutes, what you would normally take them a day. Another story that comes to mind is that we had, on more than one occasion, we had a customer saying that they've chased a bug for over 6 months because in the production environments, there was a multitude of factors that were very hard to predict. A combination of user inputs and per user customizations and so on. And I remember one case where there was an anti-fraud system where the user could configure his own rules for anti-fraud. And that combination of rules led to a miscast somewhere. And this involved currency changes and specific accounts configurations and so much stuff that was very hard to simulate accurately. And so they've chased that bug for over 6 months due to their inability to see what's going on in the system accurately.
Again, very familiar situations. I think a lot of it still continues in many organizations, even those that have the best software developers and really, really solid software teams. Even now looking at the advent of so many tools coming in. For example, recently I was reading an article on, infrastructure as a service where, it talks about CI/CD pipelines, the provisioning environments, managing configurations, provisioning security, and all of this typically running through several pipes and then so many interconnections. I can only imagine even internally provisioning infrastructure in an organization is becoming hugely challenging for people, IT administrators, or people who have to know a little bit about all the components that exist in their system.
Setting up environments in a way has always been difficult to computer engineering. I remember back when I was managing project, we had to order servers a few months ahead of time to make sure we had compute capacity. In a way, the world keeps turning and infrastructure has always been a problem, whether it's production environments, whether it's development environments. Things were never easy. With shedding off physical computers and now even shedding off virtual computers, moving on to cloud native stuff, we're dropping our challenges. We're just getting a new set of challenges. And cloud native environments, whether it's Kubernetes or a serverless and so on, they are very complex. They tend to be much more complex than their predecessors. They do bring a lot of benefits, especially if you're looking to create larger teams and larger and more complex software and scale it faster, both from an engineering perspective and from a performance perspective. Then cloud native offers many, many benefits. It's quite something everyone should look into. But at the same time, it also creates a set of challenges. All of a sudden, instead of just spinning up one monolithic applications, you're spinning up dozens of microservices, sometimes hundreds of microservices. They may be written in different environments, different languages. They may be running under different technologies. You may be relying on various cloud-only resources that are hard to simulate locally. And all of a sudden, spinning up those environments become complex. It's no longer just a matter of building and running your software, the software you've just developed on your machine, because there are so many dependencies and you need something to help you orchestrate those. And there are best practices on how do you minimize those dependencies, and yet nothing is perfect and there are always going to be dependencies. And especially when it comes to the more complex bugs and more difficult to solve issues, dependencies are going to be a big part of that. And using tools such as Rookout, you can actually work in any environment of your choice. Because keep in mind, even if you did manage to spin up that environment on yourself or using scripts provided by your IT department, that environment becomes very opaque because you can't just attach a debugger to a pod running in Kubernetes, especially not if it's load balanced and there are 3 of those. Things can become very, very finicky. And cloud native development, cloud native debugging definitely requires a new set of tools, allow us to work efficiently.
What you've shared, on the one hand, feels like systems are quite fragile and becoming more complex. What would be your thoughts on building more simple and yet robust systems to handle the kind of complexity, problems of scale that we're likely to see with an explosion of, especially in the last few years and most recently in the last 1 year, with all the challenges that people have had working remotely and suddenly understanding the need to become digital. So I see that it's going to become more and more complex, and yet we need a certain degree of simplicity and a lot of robustness in place for people to be able to sort of successfully manage, provision, and deploy such systems.
Definitely. Nothing is more important than simplicity. And I have a few thoughts on that. First is that, of course, if you want to make stuff more understandable, I think since our first introduction to software engineering, simplicity paramount. Simplicity is the best feature in any software. It's going to make your software easier to understand, easier to execute, easier to develop, less bugs. Simplicity is king. It's the best thing ever. And yet, it tends to be our sin as a software engineering professional and IT professional in general, create unnecessary complexity. Whether as software engineers who want to use a new technology or build a feature better or smarter or more future-proof, we go for a more complex solution that's often unnecessary. The product manager and project managers who are working with often, and the customers often create that unnecessary complexity as well. Defining features that might not be needed yet, and adding more overhead to the system. And every time we truly be our best selves, every time we make things as simple as they can get, we are going to build a better system that's going to be more future-proof. While every time we give in to ourselves and to our colleagues and add complexity that's not going to be needed there, then that's the true tech debt, because that's going to be harder to understand down the road. And I remember a friend of mine who said a few months ago that as systems grow, especially whether it's a very large monolithic applications or whether it's a microservices, cloud native applications, then once you build it all together, once you integrate all the Lego pieces, then that's going to create its own set of complexity. Now, if each component by itself is fairly simple, fairly straightforward, and complexity becomes from the whole of the system, then it's going to be complex, but it's going to be understandable and it's going to be reasonably predictable. While if you allow each component by itself to become complex, then once you add the second degree of interaction between components, then things are just going to spiral out of hand and things are going to be very fragile. At the same time, if you create that simplicity in each component, then you have a good chance of being able to use the interactions to build resilience, because you'll be able to predict what's going on.
That's very nicely put, Liran. Thank you. So one question, that's coming to my mind, and you spoke about it, are the layers of complexity that get built in, again, through human intervention in the creation of a software product or a solution. And it's either the creativity of a developer or what a project manager or a product manager would add, along with customer aspirations, which are invisible yet very powerful forces that sort of shape a product in some sense. So, how would you design simple yet efficient and solid systems in this highly interconnected world that exists today?
First and foremost, reduce the scope of the project. Start small, work agile, add stuff step by step. Obviously, if you do add stuff step by step and you keep it very simple, then there are going to be stuff you're going to have to rewrite. There are going to be stuff that's going to be wrong and you're going to have to fix. But let's face it, we're going to get stuff wrong anyway. And if you try to do it all at once, we're much more likely to over-engineer and over-require. So the first two steps are work agile and start small, add requirements only as they're needed. And also keep in mind that also non-functional requirements such as security and availability can make as much of a headache as the functional requirements, as what a product can do. So you have to keep both in mind. Obviously, the better software engineers you're going to hire, the better solution they're going to find to the same problem. A better software engineer is going to find a simpler solution to the same problem. Use high-level components by using higher-level languages, by using newer runtimes, by using services managed by the cloud providers, by using open source code. You're going to be handing off some of that complexity to others. That's hopefully going to make your part of not as complex. And also, obviously, all the design principles of software engineering, abstraction, isolation, and so on and so forth, those are all key elements in properly designing the system to be simple.
You talked about an agile way of working, in order to build a really solid system. What, in your experience, is a good agile software team look like? What are the kind of composition or skills or nature of such a team that can, build this kind of software?
I think in a way, a good agile software team is all about the togetherness. It's all about being a team. Teams, from a technical perspective, things can shift very dramatically. Sometimes 2 people or 3 people is more than enough for a team, while other teams might go as high as 10. Sometimes you need multiple designers because the software is very UI intensive, while other times you might not need even a single designer. You might need very different skill sets, whether it's a Java or JavaScript or web, or sometimes even C and assembly. There isn't a specific set of skill set, but it's very much about having the team together. It's about having the teams both aligned internally, having them in good terms, the best terms possible with each other, and making sure each has each other's back and trying to teach and learn each other. On the other hand, it's about being aligned with the organizations, having a clear set of goals, possible measurable KPIs, and having that team that's well aligned internally, working toward the same goal that's serving the organization.
And how do those teams maintain, how do they build up first a certain velocity and yet keep, the eye on the quality as well? Because these are two key things that, at least in my experiences, I've seen a lot of software teams struggle with is, rather than creating a buildup of velocity, they use velocity as a measure of, how productive a team is. To me, it's also a balance between whether you're delivering really solid code and code of value to the customer, rather than just trying to get to achieve a certain velocity.
As you mentioned, software engineering is a very young discipline. And when it comes to measuring, we're still very young. We haven't got there yet. In fact, most of the so-called numerical measuring we're seeing is often very biased and actually based on numbers that are estimated by people rather than numbers that are measured through instruments, so to speak. And I think the number, when it comes to team, when it comes to quality, when it comes to velocity, the number one thing we should count on is feedback. Nothing is more important than feedback when it comes to writing software. And there are a few things to do to make sure that. First, feedback is based on loop. You do something and then you watch the feedback. And the shorter the feedback loop is, the better it is for you. The more you can observe and make a change or make a hypothesis and see what's going on and then adapt, the better it is. And so if you manage continuous integration earlier and automated building and so on, and all that is crucial. The faster you can build, the faster you can release, the faster you're going to get feedback. You have to rely on that feedback, whether you're doing, I have to say, there is no wrong cycle. I mean, some companies out there are still doing it quarterly, and maybe there are issues and it can't be done. But for most companies, to take it one step at a time, try to be more agile. Every release, every time you do it. I know at Rookout, we got to the point that we release software multiple times a day. That has been a journey for us, but it's been very rewarding, both from an engineering perspective and from a business perspective. And then you have to rely on feedback. And keep in mind, quality is not an absolute factor. It's not an absolute scale. What for some companies might seem an amazing quality, may look as terrible quality for others. Just to give you a very quick example from Rookout, 4 years ago, when we just started developing, our product was only used for demos. So our tolerance for quality was as long as the demo passes, and maybe with a few visual artifacts, but as long as the demo works well, then the software quality is high because the software is only used for demos. Today, with the software being used hundreds of companies in Fortune 500 production environments, then working in a demo environment, that doesn't cut it anymore. All of a sudden, there are very strict performance concerns, security concerns. And when you have hundreds of users using your systems and maybe thousands, then every small bug makes a much bigger impact. And so we see that from month to month, our quality standard rise as the business gives us feedback that what we've been doing is not good enough. And so I think that's the most important thing when you're trying to balance quality and quantity. If your quality is too low and you have a good feedback loop, somebody is going to let you know, whether it's going to be your KPIs, whether it's going to be your sales people or marketing people or customer support people. If you let quality drop too low, then they're going to let you know. And once you know that your quality is too low, then work on improving it. Create better testing tools, work in smaller pieces, create gradual rollout strategies, but make sure to increase quality. On the other hand, if nobody is complaining about quality at all, then maybe you can take a step back, let it drop a little bit in order to move faster, obviously. Try to move a bit faster. You can risk breaking some stuff. And if you're not hearing any feedback about it, if nobody cares about the lower quality, but it allowed you to achieve higher velocity, then that's awesome. You've done the right thing. While if somebody says, hey, quality is too low, we can't afford that, then you've gone too far and you have to take a step back.
Nicely put together, Liran. Thank you. So as we are coming to the end of this particular episode, are there a few messages that you would like to share for young people, either aspiring to be software developers and, wishing to make their careers in tech?
I think the most important message for folks who are thinking of becoming software engineers is that software engineering can be hard, but it's hard for all of us. In many ways, software engineering is the pursuit of perfection because machines, at least for now, don't understand our intentions. They just do what we tell them to do. And if what we tell them is in any way wrong, then they're going to do that wrong thing and we're going to have a bug, we're going to have an issue. Software engineering is the pursuit of building the perfect software, and we're never going to get there, and it's hard for all of us. So you shouldn't be worried about it being a journey. Don't be worried about it being complex or taking time or failing. We all fail all the time, and it's about knowing when you can fail, knowing how you can fail, and having the tools in place and the mentality in place to pick yourself up from those failures and keep going.
Thanks, Liran. Thank you very much for your time. It was a real pleasure that you reached out to us and we got the opportunity to have this conversation.
My pleasure.
We thank Siddharth for the music and Malavika for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.
This podcast was created on Hubhopper Studio. If you wish to start your own podcast for free, visit www.hubhopperstudio.com. Hubhopper is India's leading podcast creation platform. Start your podcast with Hubhopper Studio and you get your voice heard across platforms like Spotify, Gaana, Google Podcasts, Wink Music, and more. Click on the link in the episode description or visit www.hubhopperstudio.com.